Hi, this is John Bleiler, Editorial Director for IoT Embedded Systems, and today I'm talking with Warren Kurisu, who is the Director of Product Management at Mentor Graphics.
Customers are now starting to build cloud into their strategies, and so they want to continue to use their embedded operating environments, but then extend those into the cloud. Last November at the Minds and Machines conference that GE holds every year, Jeff Immelt was saying that one of the big problems in the industry is that productivity has gone down. All sorts of manufacturers of anything, it could be manufacturers of cars or yogurt or whatever it is, they're looking at ways that they can improve their operational efficiency and grow their efficiencies, and everyone's looking at the cloud as a way of doing it, Microsoft. So really what we're bringing to the game is a complete development environment integrated with Microsoft Azure SDK, which allows customers to take those systems now and connect them up into the Azure cloud and benefit from all of that big investment that Microsoft's made in terms of data storage, analytics, data access through the Azure solution.
And I know here at the show you have a game machine going on that does exactly that too. Do you maybe mention that briefly?
Yeah, on the game machine, what we have is a system that collects biometric data from a player. The game itself is the memory game. A child, you play the game where you flip over cards, you kind of remember where they are, then you flip them all upside down and you see how many pairs you could get. Well, we have the modern day equivalent to that, where we're running both our Nucleus and Mentor Embedded Linux to drive the overall system. And the way the game works is we start with a tablet, where a game player enters their information. They enter some physical biometric data, such as how much did you sleep, do you exercise, when did you last eat, do you drink caffeine, and then they play the game. But before they play the game, we also put a brainwave collection sensor on their head, and we also gather mental biometrics as well as the physical biometrics. So now we have this biometric information. While they're playing the game, we're gathering the brainwave data. We're doing some correlation analysis to game performance to the brainwaves, and then at the end of the game, we do some final correlation analysis in our gateway. So our gateway is running the Mentor Embedded Linux with the Azure SDK, and then we communicate all that data back up into the Azure cloud, and then we present the final aggregated big data results from all the people who have played the game, which now numbers in the hundreds and hundreds of people played this game. And so we're able to see things like, if you drink caffeine, your memory recall is going to be a little bit better, even more so than if you've slept a lot.
All right. So it sounds like the cloud activities, the cloud solution, the gathering, storing, looking at the data. That's fantastic. That's pretty much the end of the story then, right? Or what happens when that comes back and you want to put it now into your system and get some value there from it?
Yeah, well, so it's not quite the end of the story. There's a lot more work that needs to be done, and I think developers of devices that need to tie into the cloud need to be aware that if you look at Microsoft Azure, for example, they have a lot of great technology up in the cloud, and then they have the SDK. And the combination of the stuff in the cloud and the stuff that's integrated on the end device, whether it be a gateway or an edge device of some sort, those capabilities are really frameworks for doing things like resetting a device, identifying a device, provisioning, managing, authenticating a device, doing bulk uploads and downloads, being able to do remote software updates. Those sorts of things are really critical for basic operations for any of these cloud-connected devices. But where the real work is integrating that with the rest of the system. So there's hardware dependencies, there's operating system dependencies, how you want to do your software updates. It all depends on the use case. So there's this whole big piece of work that underlies the framework in the embedded device that needs to happen.
All right. So do you have examples of other things that extend beyond the cloud? I mean, that focus more on the SDK.
Yeah, absolutely. So the SDK, for the Azure SDK, it enables a bunch of stuff, right? That's just part of the SDK. There are other things that a customer may need done with their device. For example, if they're worried about predicting failures, for example. One of the things we can do, and we've been doing for a long time, is we could instrument parts of their devices. So we could look at memory usage, we look at CPU utilization, we could look at power management states. And that sort of information we can also make available up into the cloud. And that could be used for things like predictive maintenance. I was at a conference earlier this year, and there was this company that builds automatic doors. So if you go into the grocery store, you walk up, the sensor opens up the door, right? But this specific company had problems with these things failing all the time. And so what they did was they basically cloud connected their doors. They were able to do they were able to predict failures and do predictive maintenance on those doors. So this door company was basically saying, well, not only do they have a happy customer, but now they're being recognized as one of the quality leaders in the industry. And it's not because they improved the mechanics or they improved the software. It's because they instrumented what they had already built, and they put that data up into the cloud, and they're able to do some advanced analytics on it. So likewise, for anybody that's using our Linux or our Nucleus RTOS, if they want to be able to gather that kind of low-level data that may be leading to some sort of unpredictable failures that might be related to maybe poor coding that causes memory leaks, for example, those are the types of things that we can provide that information back up into the cloud for customers to then ingest into their analytics engines to do things like advanced analytics and predictive and even prescriptive maintenance.
Which is a big thing in the automotive space too, and I know you guys cover that as well in a different group. But yes.